In this video, we discuss the ways of handling outliers. An outlier is a surprising or unusual observation that was obtained basically in a normal fashion in terms of the design of the study. Whereas another kind of outlier is a contaminant. It's one that it's just a mistake and basically you ignore it. In this video, we're going to be covering the discordant observations. So we're going to look at three different methods of doing this. One is a single outlier in a univariate sample, multiple outliers in a univariate sample, and linear models. Let's take a look at an example. So these are box plots. The way SPSS does box plots is there is the black line in the center, which is the median. The lower 25th percentile is the bottom of the box, and the 75th percentile is the upper of the box. And if there are no SPSS-defined outliers, the little bars, leaves at the top and bottom are the max and the minimum. Now we notice here there are some observations that are outside of that. In this case, the little bars are not the max and minimum. But this is a special way that SPSS does it. If the observation is more than the height of the box, maybe 1.5 boxes, it's called and it's defined as an outlier and it has a circle. If it's more than 3 heights of a box, it's a star and it's an outlier. So our first consideration is we're going to do, this is subject 14, and it's the lipofuscin study, and it's the average of the luminance that basically we think represents lipofuscin. And there's this value down here, observation number 79, that appears to be lower. It's an outlier on the low end side. We'll look at that first, then we'll turn to examples where there are 4 outliers, not quite as far out, but they're up. And those are multiple ones, and we have to treat them a little bit differently because there's this concept known as swamping. If you have too many up here, you don't find any outliers because as you're looking for the one that's furthest away, the others kind of bring the average up and keeps it from being defined as an outlier. The other type of method is a linear model. And actually, this is called linear, but it is a linear regression. It just happens to be y equals a plus bx plus bx squared. Now that's got a curve, but it's still called a linear model. And we look for the deviations from that to see if there are any that are outside what we might expect. We may look at this example instead of the other one because here we are talking about a linear, and this is our friend the Chow data with baseline axial length and follow-up. And we have these values up here, and this is for the aspheric group only. And these little fellows look like they might be outliers, so we might do the linear model on that. And here linear makes a little more sense because it's a straight line. But both models are called linear. So let's begin. We're going to start with this problem, and particularly subject number 14. And this is the single outlier with looking at one observation or one subject. So first, we need to split our file by ID so that we can compute the statistics for each of these. And then we also, in this particular model that we're looking at here, we also had the flash level equal to 0. So we want to have that set too. All right, now we need to get, in order to compute our Grubbs t statistic, we need to get our means and standard deviations. So we are looking at light, and we'll see what we get. So let's also, just for the heck of it, look at log light. Log light, which is down here. Because we want to check, our assumption is that we have a normal distribution. But in the case of that outlier, maybe it's well, in this case it could be a log distribution, but this is, a log would not help this one, but we'll do it anyway because we'll need it for the next time. Okay, so here we have subject 14, light. It has a mean value of 55, a standard deviation of 413, and that minimum value was 37. Let's bring in our Excel spreadsheet. And so we can calculate. Well, let's copy this. Copy, paste, and our formula is the minimum value. In this case, we're interested in the minimum. Minimum, parenthesis, minimum minus the mean divided by the standard deviation. Let me put this down where it belongs. Okay. Now, this is our t-score, and we can go to our Grubbs test for outliers. The t-score is 4.34, and our subjects are 29. So we go down, we have 25 to 30. So even using the biggest number, it's, you know, I think we should, this table is set up for a two-tailed. We spoke previously of using the one-tailed 5%, but really we should use the 2.5%. That makes it a two-tailed test. And the value is 2.91. So this number, the absolute value of this number is greater than 2.91. So we should reject that. Go down to subject 14, is right there. And there's 37. Now, we could just delete this guy, but then if we made a mistake, we'd be mad because we would forget what this number is. So let's insert a variable right here. Insert a variable. Let's call it, I double click to get straight to this spot. Let's call it outlier. Double click again and get back to it. Over 1. Now what we want to do is we want to compute a variable called outlier. We want to set all the values to 0. Now outlier already exists, so it's going to say, do I want to change the existing variable? And I'll say OK. And then we can see that it has set all these to zeros. Now let's go back down to our little guy that has a problem, 37. Let's set that outlier value to 1. And let's go to data select again. If flash level equals 0 and outlier equals 0, because we want all the outliers that are 0 and the flash levels are 0. So that 1, our bad boy who's an outlier, is a 1, so it won't be selected. Okay, now we come in here one more time, and we see that now number 79 with that value is deleted. Let's look at our descriptives. Again, descriptive, okay. Now we know our standard deviation is reduced from 231, or from 4 to 2. So that's a big savings and variability from that. When we write our paper, we actually want to present our results both ways, with and without outliers. Now let's move on to the other problem. And in this, it's going to be a little bit different because we have 4, and rather than taking the max value because of this swamping issue, we want to get rid of the largest value first and then calculate the outliers and see if it's gone. If it turns out that this is not an outlier, then we stop. But if we reject this one, then we go on and do the same procedure again. So let's see where we are. Let's look. So that's subject 13. So we come up and we find this would be, we sorted by ID and light. So this is going to be the max value for light, which is 96.575. So we're going to set our outlier to 1. And then we're going, and that will get rid of this largest outlier. We have to run filter again, select cases, if, and we just have to say OK. And now when we look at it, it's always good to check and make sure your value got deleted. There it is. Now we'll do our descriptives. We'll get our table, we'll copy it, we'll put it into Excel. So now we have this minus, what is this? Oh, that's, okay. We need to put a value in here. So let's go down and copy this. This was our univariate, our single one. And that formula is based on the minimum. Well, we don't want to use the minimum. We don't want to use the max in this case. We want to use that value that we deleted. So it was 96.575. Oh, shoot. Let's try that again. It was 96.575. All right, and now let's take our formula. Let's move it from that old minimum up to here. And we get a value of 2.29. Now we're going to use the same table. Now we have 34 observations. So we can go to the 35. We're going to use a two-tailed test, and we see that the rejection is 2.98. Now this did not quite, oh, it didn't reach at 2.29, is not close to 2.98. So it turns out that our most extreme value was an outlier. Now I suspect maybe if we got rid of all 4 of those it'd come out, but it's not enough of an outlier. It just isn't far enough out to be an outlier. Now if it was an outlier, we would then delete the next highest value, or set it as an outlier, copy our descriptives again, print that value into there, which would be 96.545. We'd put that there. We calculate again and see if we could delete. We do that up to 4 times because we decided that there were 4 potential outliers. As it turns out, none of them were. So that's how you do the multi-one. The next thing we want to do is look at the linear problem. Now, just a reminder, this was the data set we were just looking at with the LipoFusion, but first of all, we don't like this curve because it goes down. It's not a true curve. And in fact, if we had another thing on general linear models, what fits very well to this data is an inverse regression equation as opposed to a linear regression. That's a nonlinear model, and it works pretty well, but we're not going to do that right now. Instead, we're going to go back to our familiar Chow data with 5 years and baseline, and we're looking at aspheric lenses, and we want to know if any of these values are outliers. So what we're going to do is we're going to analyze. First we need to select if, nuts, I'm not in the right place. Let's go to Chow. So let's go to Data, Select, and then we want the aspheric ones, which is if lens type equals 1. Okay, and we're going to look at everybody in that case. So we have aspheric, no slashes, just checking. We have spherical, lots of slashes. So we have gotten rid of the spherical values and we've done our graph. Now let's go do a regression. Regression, linear, and we want 5-year as a function of baseline. Now we want to save our residuals, and actually we want to save our studentized residuals because that's going to give us the t-test. And now, unlike, we're not going to use the Grubbs table or anything like that. We're just going to arbitrarily set to delete observations that have a studentized t-test greater than 3. We could use 2 or 2.5. Let's see how close we get with 3. So we have our studentized residual. There's no values here because we've filtered those out. So let's data sort our cases by our studentized residual. And then let's see who we got rid of, who we would get rid of. Come down here. And here's 2.69. Now these are guys that are less. They're the ones probably falling below the line of identity. We could get rid of some of those if we wanted to. Let's go up at the other end. This seems like it's almost a good candidate for a trimmed mean. We get rid of, because there's outliers on both sides. But here we see that we have 475, 423, 3.8. There's 4 values that we would get rid of. And if we plot, let me get rid of that filter there. Select cases, if Okay. Let's do our plot again. We've sorted it so the observation numbers come out wrong, but we're 375 to 378. So scatter plot. Okay. Now, double click on this. This little symbol right here is what tells us what the observations are. So that's 376, 375, 377, and 378. So those are our 4 outliers that are greater than 3. I think that's correct. Let's look again. Yeah, everybody greater than 3. We could go down to 2.5 and we would get rid of one more at that end, and then at the other end we'd get rid of observation 190 as well. So, but I think we're happy getting rid of 3s. There's a pretty big jump from 279 351. You could also say there's kind of a big jump there too, but that's how you do outliers with the linear model.